Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. For all the students that have taken my class in real life, they can tell you I am not a geometry person. I like algebra so much better. So now that we're moving into the land of trig here on this channel, you might think that I'll revert back to like, oh my goodness, I am not a lover of geometry. However, this isn't geometry to me. This is algebra geometry. This is the kind of geometry I can get and I am good at. And I really see its use in different places in real life. So I guess I get a little more into this than I do the study of triangles. But keep in mind here, we're going to go ahead and just in general, if I say the unit circle, I mean this circle here. It's centered at 0, 0. It has a radius of 1, so this is the ordered pair 1, 0, 0, 1, positive 1, sorry about that, negative 1, 0, and 0, negative 1. And those coordinates are very important. However, we're just going to go over what they are talking about if they talk about an arc or an angle. However, we are also going to refresh some memory of just some stuff. This is an ordered pair, x, y. I could have done it anywhere on the circle. We know my radius is 1. And I can make a right triangle out of that. This is x, this is y, this is a right triangle. I know x squared plus y squared is going to equal 1 for every single ordered pair on this circle. Okay? Because my radius is 1 unit. If I talk about a positive arc or a positive angle, what I'm saying is we're starting from this part right here. We're starting out here and we're going up. Because in a positive angle, we go up. We go through the first quadrant, into the second quadrant, around to the third quadrant. If I wanted you to do a negative, instead of going up, we would go down. So when I say positive or negative, I'm just talking about the direction. And hopefully you guys remember that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so now you might understand why they're numbered 1, 2, 3, 4 in that order. It's because we went up from the start in a positive manner. Okay. This is going to be your angle, because we always stand at the origin. And this will be an arc length. Okay, so the angle is the size, and it's going to be measured in radians. So an angle is, so when I talk about theta, it's measuring your angle. It's going to be measured in degrees or in radians. Okay, if I talk about your arc length, now that's measured in units such as meters, feet, inches, etc. Okay. So when we talk about this, we're going to have our starting side and our ending side. Our ending side is called the terminating end or terminal side. Or they might just talk about the point and say the terminal point. Okay? So we're going to go through some refreshing of what are some skills you have. So first of all, I want to find the circumference of the unit circle. Okay, and I'm going to draw some various arc lengths and things like that. Find the circumference. And we're going to do a full circle. And remember, the unit circle has a radius of 1. So if you remember, the formula for circumference is 2 pi r, and since our radius is 1, our circumference is 2 pi. Okay, so let's look at several arcs, and we're going to think about them with proportionality in mind. Okay. Okay. I'm drawing these all in a positive direction. Okay, so I've drawn 3 different arcs. Okay. So, what's the arc length? Well, think about this. If the full thing is 2 pi, what's a quarter of it? Okay, so if we divide it into 4, we get pi over 2. Because 2 pi's split between 4 people, each person gets half a pi. What if you have 2 pi split between, that's a half circle, just 2 people? You get 1 pi, right? So it's like each little quadrant is a half pi. I kind of joke with my students, run half a lap, get a pi, run half a lap, get a pi, run half a lap, get a pi. So you do half a lap and then you almost make it back to your next pi. Oh, you get 1.5 pi's, or, okay. So now let's go backwards. If I tell you your arc length is 3 pi, could you draw the arc? Well, half a pi, or sorry, half a pi, 1 pi, 1.5, 2, 2.5, 3. There would be our terminating point. Okay. What if it were negative pi? Oh, well, that's like pi, but we go backwards. You just ran backwards on the track, which I don't know if you've ever ran backwards on a track. It feels really weird to do. Not as in like needing rearview mirrors, but like if you go the opposite direction that everybody races in. Okay, and let's do negative 3 pi over 2. Okay, which is 1 1/2, right? So halfway between 1 and 2. We have to go down because it's negative. Okay, now you might have noticed that this one here and this one here end at the same place. They terminate at the same place, so they are coterminal. Now, you also might have noticed that this one, and this one all ended in the same place. So they are also coterminal. In fact, we could draw infinite numbers of coterminals. Like if you think about all the races that finish in the same spot, like they start at the same spot and they end at the same spot, like the 400. They start at the starting line, they end at that same line. The 800, the 1200, the 1600, the 3200. Some people just do more laps than the other, but they still start and end in the exact same location. So we have to keep that in mind, okay? And I can actually get ordered pairs from all of those, okay? So let's see if you can think about the ordered pairs that would go with a terminating spot of an arc length pi over 4. Okay, so let's think about how big is that arc length of pi over 4. Okay, 0 is here, right? Pi. This was pi over 2. This was 3 pi over 2. And when we got back to here, we've got our full 2 pi. But this is pi over 4, so it's not even, oh, it's a quarter of a pi. So if this is no pi and this is half a pi, a quarter of a pi would be right smack dab in the middle. And remember, we're on the unit circle, so our radius is 1. And I'm going to go ahead and write pi over 4 here because that's our arc angle that we did. But there's some kind of triangle going on here. However, if you remember, this is perfectly in the middle, right? It's a 50-50 split, so instead of 90 degrees, this is 45 degrees. So this is really the 45 degree, 45 degree, 90 degree that we had in geometry. So even though this is x and y, we know x equals y, because if two angles are equal, two sides are equal, okay? Or we know a 45, 45, 90 triangle from geometry days had a 1, 1 square root of 2 relationship. Instead of a hypotenuse of square root of 2, though, we have a hypotenuse of 1. Could you get x and y? Yeah. So cross product, 1 equals root 2y. 1 over root 2 equals y. So y is equal to root 2 over 2. Now we have our coordinate. X and y are the same, so root 2 over 2, comma, root 2 over 2. Interesting enough, what if I said that our t value was at 3 pi over 4? Okay, so 3/4 of a pi. So none, half, 3/4. Radius is still 1. This still split the 90 degrees into a 45, 45, 90, so it's going to have the same leg lengths as this. Except now we go left and up. So left root 2 over 2, up root 2 over 2. I could do this in any of the quadrants. In fact, it's so popular that we have the unit circle, and you can print these out. But I love this one because it's color-coded. We can see all the ordered pairs. Now, pi over 6 has the same, see how it's out and up the same amount as 5 pi over 6? Pi over 4 and 3 pi over 4, out and up the same amount. Pi over 3, out and up the same as 2 pi over 3. Because we always use the x-axis as the x part. We go over and then up, or over and then down, but you're always using the x-axis. So anytime you make triangles, make sure your one leg is on the x-axis. Never the y-axis, always the x-axis, because it's your independent variable, it has all the control. But these are our very popular angles. You'll notice that it's the same 3 angles in reference, like this distance, this distance, this distance. Like you could fold these over and they would meet, and then you could fold them. This distance here is the same as these 3. The distance to here is repeated in the other 3 quadrants. The distance to here is repeated in the other 3 quadrants. It's just the same reference triangle used over and over and over again, and it's a really, really big part of trig. Now there is a hand trick you can learn and things like that to help you remember, but if you're trying to just memorize the unit circle, something you can think about is everything is over 2. The outside is the square root of 1, square root of 2, square root of 3. The inside is the reverse, the square root of 3, the square root of 2, the square root of 1. That's it. And they get repeated. So if you can memorize one of them, the other is the reverse, and then you just have to adjust your angles. So, kind of neat. Unit circle, very, very, very helpful. It's going to go a long way if you know this information in trig. I actually don't have it memorized because I have a different way of doing this memorized, and it just works for me better. So I use triangles instead of the unit circle, and I find that I like that better, but many people use the unit circle and they just know this thing. Okay, so something else you might be asked to find is if they give you t, could you find this? Okay, and what this is called I kind of alluded to it, it's your reference angle. It's the shortest arc length to the x-axis. And it will always be positive. So technically, absolute value. I don't care whether you're going up or down. I don't care. So some of them seem kind of silly to try to do. But I'm just going to give you some different t values. So t, we'll put t in this column and t bar. All right, our first one's going to be 5 pi over 6. So 5 pi over 6 is here. Because this is half, this is 1, this is 1.5, and this is 2. So 5 pi over 6 is right here. And we need, how far is it? Closest we can get to the x-axis. Well, this piece is a pi over 6 length because these two will add to 1 pi, which is the axis that we went to. Oh, hey, come on. Okay. What about negative 7 pi over 4? Let me erase most of that. So negative 7 pi, so negative 1, negative 1.5, negative 1 3/4. We're in the first quadrant, and we need to get that completed circle, right? We're missing a little bit of the circle. We're missing 1/4 of a pi. So there we had to think about what made the full circle. Okay. What if I said two pi over 5? Okay, so that's not even half a pi. We're somewhere in here. How far are we away from the x-axis? Well, the shortest distance from the x-axis is 2 pi over 5. And that can happen. All right, I have one last one. 5.8. Wait a second. We've been doing things as 0, pi over 2, pi, 3 pi over 2, 2 pi. That's 5.8, that's a decimal. Okay. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So 5.8 falls between these two. Okay. So I'm here. So the shortest distance back to the x-axis is however far we are from 2 pi. So I've got to do the 2 pi number minus 5.8. 0.48. Which, I mean, It's less than half a pi, so we did good. So when they do things in decimal form, you're going to have to change your 2 pi to 6.28, your 3 pi over 2 to 4.71, your pi to 3.14, and your pi over 2 to 1.57. And we know those are approximations. But just keep that in mind, that that's what they're talking about. And they'll use the word for that as they'll say the reference angle, the reference arc. And it's really important that you understand that relationship so that you can do all the trig functions in geometry correctly. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.